Next question is we have to solve 1 plus sec a upon sec a is equal to sine square a upon 1 minus cos a. So there's a hint that we need to simplify LHS and RHS separately. Right, so we have to arrive at some answer using this left hand side and then solve this RHS to get the same answer. Right, so see here you have sec a and here you have sine a and cos a. Right, so since you need cos a and sine a, so you won't be able to get that using sec a. So you have to convert this to cos, because we know that sec a is equal to 1 upon cos a, right? So if we solve this left hand side, we'll get 1 plus 1 upon cos a. This is divided by 1 upon cos a. Right, so this becomes cos a plus 1 upon cos a. This is divided by 1 upon cos a. Right, so this 2 cos a will get cancelled, so we'll end up with cos a plus 1. Right, so here since it is given that we need to simplify LHS and RHS separately, so what we'll do, we'll use this RHS to arrive at this cos a because we cannot simplify this further. RHS it is given, say we'll consider two cases. Here it is given, right? So what you'll do, sine square a upon 1 minus cos a. Right, so as I mentioned previously, this is an indication on how you can further simplify it. So you can write, so see, you have cos a in the denominator, you have sine a in the numerator. You have to convert sine a in terms of cos a. So we'll use the identity sine square a plus cos square a equals to 1. So we'll get sine square a is equal to 1 minus cos square, right? And then we have 1 minus cos a. Yeah, so this will be 1 plus cos a times 1 minus cos a upon 1 minus cos a. Right, so 1 minus cos a, 1 minus cos a gets cancelled. So we end up with 1 plus cos a. Right, so I mean, now both RHS and LHS are the same. Now say if this was not given, you had to arrive at this answer just using this. So what you'll do, you'll simplify the RHS in your rough work, right? So whatever rough work you do, you'll try to simplify this RHS. And you get this. And this from here, you reached here. So that means you have to reverse this process here. So now next step, what you'll do, so you had 1 plus cos a already. So you'll multiply both sides by 1 minus cos a and divide 1 minus cos a. So you'll do multiplied by 1 minus cos a and then divide this by 1 minus cos a. So this will not change the result, right? And then this will be, this is of the form 1 a plus b and a minus b. So this becomes a square minus b square, or 1 square minus cos square a upon 1 minus cos a. So 1 minus cos square a is sine square a. So this becomes sine square a upon 1 minus cos a. Then we have cos a minus sine a plus 1 upon cos a plus sine a minus 1 is equal to cosec a plus cot a. And they have specified that you have to use this identity, cosec square a is equal to 1 plus cot square a. Right? So they have specified it. Otherwise, we could have also used cos square a plus sine square a is equal to 1. Right? How, I mean, we can split it. So once you look this pattern, like there is a conjugate pattern, cos a minus sine a plus 1, cos a plus sine a minus 1. Then you have to multiply it with its conjugate. Right? So here what we could have done is we could have written cos a minus, because this is changing, right? So we can write cos A minus sin A minus 1. And the denominator will be cos A plus sin A minus 1. Right. Now what we can do, what we need to do is we need to, because we cannot further simplify this. Why? Because cos A and sin A, there is no such relation. We have a relation between cos square A and sin square A. So somehow we have to make this cos square A and sin square A. Right. How do we make it? And we should also keep in mind what is the number that we should multiply with. So what I'm trying to say is if you have terms in the numerator, right? If you have terms in the numerator, that means you don't need much terms in the denominator. So in the denominator, you multiply with such a number such that you get the identity a square minus b square in the denominator. And the numerator, you should multiply with such a number such that you get an identity of the form a plus b whole square or a minus b whole square. Right. So this ensures there is no additional term. And this ensures there are additional terms. So if you do this in the denominator, then it will make the computations complex. Right? Now see, we'll not be using this thing. Why? Because the question specifically mentions that we have to use the identity cos x square is equal to 1 plus cot square. So we have to first convert this to cosec and cot. How do we convert this? First of all, let us see what cosec is. Cosec is 1 upon sine. And cot is cos upon sine. So we are given 1, right? So we are given 1 here. And then we are given cos as well here. So if I divide both of these with sine, so sine and sine will become 1, cos and sine will become cot, and 1 and cos will become, what will this become? It will become cosec, right? So now again, this approach we are not following. We are first of all going to divide everything with sine, right? Why are we not following this approach? Because it is not saying that use the identity sine square a plus cos square a is equal to 1. That is why we don't go by this approach. We have to divide both sides by sine a. So cos A upon sin A will give us cot A. And sin A upon sin A will give us 1. And 1 upon sin A gives us cosec A. Right. In the denominator, we'll have again cot A plus 1 minus cosec A. Right. So again, if we simplify this, we get cot A, the same thing. So cot A minus 1 minus cosec A. Denominator will have cot A plus 1 minus cosec. Right. Now what we need to do, as we discussed, we don't need any terms in the denominator, so we'll multiply with such a number such that we get a square minus b square. Right, so this is already a plus b, right? So we should multiply with a minus b on the both sides. Okay, so we'll do cot a plus, sorry, minus, because we want to do a minus b whole square. So minus 1 minus cosec a. Right, so this will be whole square. And then in the denominator we'll have, so this is, if you multiply, then it will become whole square. In the denominator, we'll have cot A minus 1 minus cosec A. So cot A square, so this will be cot A square minus 1 minus cosec A whole square. Right, numerator it will be, so cot A minus 1 minus, sorry, yeah, so it will be like this. Right, so what we are here doing is we have cot A minus 1 minus cosec A, right? And cot A plus 1 plus cosec A. What I want to have in the denominator is a term like A square minus B square. So what I multiply the both term is, I multiply the both term, both the numerator and denominator with cot A minus 1 minus cosec A. Because if I multiply it with this, I'll get a term like uh, cot square A minus 1 minus cosec A whole square. Right? There's no additional term. And in the numerator, I'll get cot A minus 1 minus cosec A whole square. So that is why I selected this thing, cot A minus 1 minus cosec A, to multiply both sides. Right? And once I multiply this, I get cot A minus 1 minus cosec A whole square in the numerator and cot square A minus 1 minus cosec A whole square. Right? So this will become cot square A, so A square plus 1 minus cosec A whole square, which is B square, minus 2 cot A times 1 minus cosec A. Right? Denominator will have cot square A minus, so this will become 1 plus cosec square A minus 2 cosec A. So this is A square and B square is 1 minus cosec A whole square. So we have to further simplify this or expand this. So if I expand this, I'll get 1 plus cosec square A minus 2 cosec A. Then we have, again in the numerator, if we solve, so we get cot square A plus, so this will be, so cot square A plus 1 plus cosec square A minus 2 cosec A. Right? So, and then we get minus 2 cot A and then plus 2 cot A with cosec A. Right? So this is what we'll get. So cot square A is cot square A. This will be 1 plus cosec square A minus 2 cosec A. So what we have written here. And then minus 2 cot A, and then minus and minus becomes plus. So plus 2 cot A cosec A. Right? Because I mean this is minus 2 cot A and minus will become plus. So 2 cot A cosec A. Then we have in the denominator we have, so we can simplify it here itself. So cot square A minus 1 minus cosec square A plus 2 cosec A. Right? You know that cosec square A minus cot square A is equal to 1. Because cosec square A is 1 plus cot square A. Now, cot square A minus cosec square A should be equal to minus 1. So we'll write minus 1 plus 2 cosec A. Right? So this becomes 2 cosec A minus 2. So denominator is right? So this is the denominator. Now what we have in the numerator is cot square a plus 1 plus cosec square a minus 2 cosec a minus 2 cot a. So now what we can do is we can just write either cot square a. So because we have to eliminate this cosec a minus 2, right? So it is better that we write everything in terms of cosec so that we can take out common terms and then eliminate this, right? So what we'll do, we'll write cot square a plus 1 as cosec square a. We can write it like this because it is given. So this becomes cosec square a, and cosec square a plus cosec square a becomes 2 cosec square a. Right, so 2 cosec square a minus 2 cosec a minus 2 cot a plus 2 cot a cosec a. Right, now I just have to find this 2 cosec a minus 2. Right, so if I take cosec a common, I'll get 2 cosec a minus 2 here. And if I take cot a common here, I'll get 2 cosec a minus 2. So I can factorize. So I'm just solving for the numerator now. So cosec a common here. So 2 cosec a minus 2. And then, here we have to, first we want to write, so we'll just rearrange this. Why? First I want cosec a. Cosec a should be in positive. Right, so instead of writing it like this, I can form it like 2 cot a cosec a minus 2 cot a. Right, so then we can take cot a as common, and then we'll get 2 cosec a minus 2. So this becomes cosec a minus cot a and multiplied with 2 cosec a minus 2. Denominator we already had 2 cosec a minus 2. So this and this gets cancelled. We end up with cosec a minus cot a. Okay, it is plus cot a. Yeah. So here we have to just take cot a common, right? Not minus cot a. Right, because we rearranged it. We are not writing minus 2 cot a plus, we are writing plus 2 cot a cosec a minus 2 cot a. Right. So if I take plus cot a as common, then only I'll get 2 cosec a minus 2. If I take minus cot a, then I'll get 2 minus 2 cosec a. Right? This is the only question that requires a lot of lengthy process. So you should practice this one 2 or 3 times. Okay? Then you have root over 1 plus sine a minus upon 1 minus sine a is equal to sec a plus tan a. So how will you think about this question? So you have 1 plus sine a upon 1 minus sine a. So I have this thing under square root, and further I know that I cannot simplify this sine a any further, because if I had tan a, I could have written it as sine a upon cos a. If it was sec a, I could have written it as 1 upon cos a and then simplified it. But it is not possible here because it is already sine a. So I need to multiply it with something such that I get whole squares. Right? There are two options now. So you either multiply with 1 minus sine a or you multiply with 1 plus sine a. right? So how do you choose the correct one? Say here you can see that there is nothing in the denominator. So when there is nothing in the denominator, so denominator should never contain a plus b whole square. So it should never be of the form a plus b whole square or a minus b whole square. It should always be of the form a square minus b square. And if the numerator has something, so here you can see numerator has something. So numerator should always be of the form a plus b whole square. So here we'll multiply this with 1 plus sine a. So I'm not taking the root over. First of all, we'll just solve for what is inside the root. So 1 plus sine a upon 1 minus sine a multiplied by 1 plus sine a upon 1 plus sine a. How does it benefit us? This will become 1 minus sine square a. Right? So whenever you see this 1 minus sine a, 1 minus cos a, this thing should strike your mind that, say, sine square a is equal to 1 minus cos square a. And this you can always write in the form of a minus b, a plus b. Right? So whenever you see terms like 1 minus sine a, 1 minus cos a, or 1 minus cos a, 1 plus cos a, this identity should come to your mind. Okay, so numerator becomes 1 plus sine a whole square. Denominator becomes 1 minus sine square. So we can write this as cos square a because sine square a plus cos square a is 1. So this becomes 1 plus sine a whole square. I am not simplifying this or I am not expanding this because this is under square root. So this square will get away. And here we'll get cos square a. Now we can take this square root over this. So if I remove this square root, I'll get 1 plus sine a upon cos a. Right? Then I can write this as 1 upon cos a plus sine a upon cos a. 1 upon cos a is sec a and sine a upon cos a is tan a. Okay, so this is the answer. Right, so if you keep on practicing more and more questions, if you just look at the question, it will come to your mind what you need to do. So for example, some of the things that we have discussed, if I have sec a, I need to convert it in the form of 1 upon cos a. If I have cos a, if I have cot a, I need to do cos a upon sine a. So first step is simplification. Right, because if you decompose anything to the form of cos a and sine a, you can just use the simplest identity, which is sine square a plus cos square a is 1. Right, if you have sec a and tan a, what you can do is you can just write it in the form of sec square a minus tan square a, which is equal to 1. Right, if you have cosec a and cot a simultaneously, you just need to use cosec square a minus cot square a. Right? And then when you see terms like this, so you should understand that you need to multiply with the conjugate. And what conjugate to multiply depends on what is given on the right hand side. So sine theta minus 2 sine cube theta upon 2 cos cube theta minus cos theta is equal to tan theta. So see, we see that this is sine theta and this is sine theta, this is cos theta and this is cos theta. So there is no further room for simplification. We just have to solve from what is given. And you know that we only have the identity for sine square theta plus cos square theta. But here what we are given? We are given sine theta and sine cube theta. Right? So if I take sine theta common, I'll get a term like sine square theta. Right? So I'll just take sine theta as common. So this will be 1 minus 2 sine square theta. Denominator, I'll take cos theta as common because it is the same form. Cos cube theta minus cos theta. So I'll just take cos theta is common, and then 2 cos square theta minus 1. Now see, this already becomes tan theta. So this should give you a hint that I should somehow make this equal to 1. So somehow this is equal to this, right? Such that it will get cancelled. So either you can write sine square theta in the form of cos square theta, or we can write cos square theta in the form of sine square theta. Both will fetch the same answer. So say if I use this denominator and write cos square theta as 1 minus sine square theta. So what do we get? So 2 times 1 minus sine square theta minus 1. This is 2 cos square theta minus 1. So, okay. So 2 times cos square theta. So cos square theta, instead of cos square theta, we wrote 1 minus sine square theta and then minus 1. So this becomes 2 minus 2 sine square theta minus 1, which becomes 1 minus 2 sine square theta. So this is equal to 1 minus 2 sine square theta. So I can first write this as tan theta times 1 minus 2 sine square theta. This is then divided by 1 minus 2 sine square theta. Because we have just proved that 2 cos square theta minus 1 is 1 minus 2 sine square theta. Both of this gets cancelled. So we have tan theta. Okay. Then we have sin a plus cosec a whole square plus cos a plus sec a whole square is 7 plus tan square a plus cot square a. Again, see, what should go into your mind is, I am given sin a plus cosec a whole square and I am given cos a plus sec a whole square. Right? So if I square this thing, I'll get sin square a. If I square this thing, I'll get cos square a. Right? And I know that sin square a plus cos square a will become 1. If I square this, I'll get cosec square a. If I square this, I'll get sec square a. Right? So cosec square a I can write in terms of cot, and sec square a I can write in terms of tan. So this, I mean, if I just expand this, this should give me the answer. Right? So we'll write sin square a plus cosec square a plus 2 sin a. Again, when I do 2 sin a cosec a, so then, I mean, if you expand this, you should also get a term like sin a cosec a. But sin a and cosec a are opposite of each other. So that gives you 2. So this is coming from there. So sin a times 1 upon sin a is equal to 1 itself, right? And then this gives you cos square a plus sec square a plus 2 cos a times sec a. So this is your left hand side. Now sin square a plus cos square a gives us 1. 2 sin a cosec a gives us 2. 2 cos a sec a gives us 2. So we got 5. Now we are left with cosec square a plus sec square a. Right, so cosec square a is 1 plus cot square a. Is this clear? How do we get this 1 plus 2 plus 2? So sin square a plus cos square a gave us 1. 2 sin a multiplied by 1 upon sin a. So sin a gets cancelled, we get 2. Similarly, cos a times 1 upon cos a gets cancelled, we get 2 again. And then cosec square a is 1 plus cot square a. So this is 5 plus 1 plus cot square a plus 1 plus tan square a. So 5 plus 1 is 6, 6 plus 1 is 7. So 7 plus tan square a plus cot square a is the answer. Okay. Then we have cos A minus sin A times sec A minus cos A is equal to 1 upon tan A plus cot A. And it says simplify LHS and RHS separately. Right. So again, we have to come up with a middle ground and then solve both sides. So if I solve cos A minus sin A, again this should come to your mind that cos A is 1 upon sin A and then minus sin A. If I do this, so I'll get 1 minus sin square A. So I can make that cos square A. Right? So I'll write this as 1 minus sin A, 1 upon sin A minus sin A multiplied with 1 upon cos A minus cos A. And then denominator will be sin A, and then this will become for this, I mean, we converted this to 1 upon sin A. Right? So we got 1 upon sin A. So we have to take the LCM. So LCM is sin A. Right? So this will become 1 minus sin square A. And this will similarly become 1 minus cos square A. So 1 minus sin square A is cos square A. So we get cos square A. And 1 minus cos square A is sin square A. Right? And denominator we have sin A cos A. So 1 sin A, 1 cos A gets cancelled. So we end up with sin A cos A. Now we cannot simplify this further. So we have to use the right hand side. Right? So what we'll do, this is sin A upon cos A and this is cos A upon sin A. So this is sin A upon cos A and this is cos A upon sin A. Right? I mean, I can tell you what you need to do here. So what you just need to do is sin A cos A. I mean, if you don't want to solve the right hand side, upon sin square A plus cos square A. How do I know this? Because you have tan A, right, in the denominator. So if you just divide this, I mean, if you just take sin square A and divide this with sin A cos A. So one gets cancelled, so you end up with tan A. And if I take sin square A plus cos square A in the denominator, it does not matter because it is equal to 1. Right, so I will just take this sin A cos A in the denominator. So I'll get 1 upon sin square A upon sin A cos A plus cos square A upon sin A cos A. Right, so this becomes 1 upon tan A plus cot A. Right, how can we know this? I mean, we just are trying to solve this, so you can do this in your rough work if it is not mentioned. And then again, arrive at this answer using this and then do back calculation to show that you're proving using the right hand side. So you'll just do cos A sin A, right, is the LCM, and then this becomes sin square A plus cos square A, and numerator you have 1. So cos A sin A comes to the numerator and denominator you'll get 1. Why? Because cos square A plus sin square A is 1. So this is equal to cos A sin A. Right? So what we got here was cos A sin A, the same thing. So again, if you do the reverse calculation, you'll see that what I need to do is, I just had sin A cos A. So I just had sin A cos A. So what I did is I wrote cos A sin A upon 1. So I'll do sin A cos A upon 1. Then this 1, I mean 1 was equal to sin square A plus cos square A. So I We'll write sine square a plus cos square a instead of 1. Right. Next, what I'll do, I have this sine square a plus cos square a upon cos a sine a. Right. So I'll take this cos a sine a to the denominator. Right. And then split it equally, which is like 1 upon sine a upon cos a plus cos a upon sine a, which is what we got here by eliminating the terms. Right. And then I have 1 plus tan a plus cot a. Is this clear? How do we do it only using one side? Then we have 1 plus tan square a upon 1 plus cot square a. So see, whenever you have plus in tan square a, whenever you have minus in tan square a, you can use this identity. Sec square a minus tan square a is equal to 1. Right, and whenever you see this 1 plus tan square a, you can just take this to the right hand side. So sec square a is equal to 1 plus tan square a, right? So 1 plus tan square a is equal to sec square a, and 1 plus cot square a is equal to cosec square a. Now sec square a upon cosec square a. So sec square a is 1 upon cos square a, and cosec square a is 1 upon sine square a. So sine square a will come at the top and cos square a below. This becomes tan square a, right? So you have proved that 1 plus tan square a upon 1 plus cot square a is tan square a. Now we need to prove that this is also equal to tan square a. Right? So when you have 1 plus tan square a, we can use this identity. However, when we have 1 minus, then we cannot use. Then we have to write it in the form of sine a upon cos a. Okay. So I mean, there is one more way in which you can solve this. So this one also there was one more way. So you could have also written it, but this one is more easier. You could have also written it like this. So 1 plus sine square a upon cos square a upon 1 plus cos square a upon sine square a. Right. So if you take the LCM, you'll get cos square a, and then this becomes cos square a plus sine square a, which is 1. Right. Similarly, denominator will again get sine square a plus cos square a, and here you'll get sine square a. So the same thing, 1 upon cos square a upon 1 upon sine square a. So sine square a comes at the top, cos square a is in the denominator. So sine square a upon cos square a is tan square a. Right, here what we have is 1 minus tan a upon 1 minus cot a. So if we try to solve this, I mean, say first of all, let us try to expand this. Because if we expand this, we'll get 1 plus tan square a plus 2 tan a. And here we'll get 1 plus cot square a plus 2 cot a. Right. So 1 plus tan square a plus 2 tan a and 1 plus cot square a plus 2 cot a. Right, so 1 plus cot square a gives us cosec square a, and 1 plus tan square a gives us sec square a. Right. So this gives us 1 plus tan square a, sec square a plus 2 tan a upon cosec square a plus 2 cot a. Right, so now we can write this as 1 upon cos square A, right? Plus 2 sin A upon cos A. And here we can write this as 1 upon sin square A plus 2 cos A upon sin. Right. So the LCM will be cos square, right here. And then here we'll get 1 plus 2 sin A cos A. And here the LCM will be sin square A. And again we'll get 1 plus 2 cos A sin A. So these two are the same thing. So they get cancelled, right? So we end up with sin square A upon cos square A, which is tan square A. Okay. So both of these are equal to tan square A. Okay. I think these are the only questions in 8.3 that we have.